Welcome to a lesson with Dr. Pal. In this video, we're going to use what we discussed in the last video about how to define sine, cosine, secant, tangent, cosecant, and cotangent via similar triangles if one side length is 1 and what the other sides are. So look at that video for a description of that. In this video, we're going to use that idea to help us quickly determine formulas and results and side lengths for different triangles. Let's start here. Let's suppose we have some triangles where we know one side length and one angle. Okay, so if we're looking at this triangle here, this looks like which of the following here from our previous video. Now notice where the side length that we know is 2. We can kind of, if you want, you can imagine your mind drawing a triangle that has, now 2 is adjacent or right next to the angle. So 2, maybe I'll make that a little smaller. Okay, so 2 right there, and the angle is 65. Now in your mind, we can think about think about a triangle with a 1 and an angle here. Which of the triangles has a 1 right here? Looks like this one. So this side length would be tangent with respect to that angle. This side length would be secant. So we can think that this side length would be tangent of 65, and this one would be secant of 65. Now, wait a minute. This triangle has a 1 right here. This one has a 2 for the adjacent. Well, all we have to do is to rescale this triangle to that one. They're similar just by multiplying all the sides by the same thing. So 2, 2, 2. That means this side length right here corresponds to 2 tangent 65. This side length right here corresponds to 2 secant of 65. So using a calculator, you can plug in 65 into a secant function or a tangent function, and you could get these sides rather quickly. Let's look at this case right over here. This 5. So think in your mind of a triangle like that with the angle down here, 70. Here is the right angle, and think of a 1 right here. Which of those triangles has a 1 right there? It looks like this one, 1. It has a cotangent there and a cosecant right there. So we think, okay, cotangent, and the angle is 70, so we can plug that into the function. Cotangent of 70 and cosecant of 70. Right, so now using a calculator, we could figure out what that is, but wait, we're interested in a triangle that has a 5 here, not a 1. So what would we do? Multiply all the side lengths here by 5. 5 times 5, 5, and then these sides would be the exact same as these ones over here. So this side length would be 5 cosecant of 70. This one would be 5 cotangent of 70. So you see, using all 6 trigonometric functions, you can quickly be able to look at something and just write down a quick statement of what these different side lengths are and know how to compute those lengths. Well, let's look at this one right here. Notice the 3 is hypotenuse. So we can kind of think, okay, and then we have a 27 degrees right here, so maybe we'll like reflect it up so we can kind of think 27 degrees and kind of think, okay, and 90, and this is not drawn to scale, but and then the hypotenuse length is 3. Notice how this looks like that one, so it's kind of reflecting or rotating or whatever we need to kind of get it looking like one of those 3 triangles that we're considering. And this 3 is on the hypotenuse. So why don't we come over here and just think of it first as a 1. And then we think, okay, so the triangle it looks like would be this one with a 1 right there. So we have a sine of theta and a cosine of theta. Cosine of theta is the length that's adjacent to theta. Sine theta is the length that's opposite. Okay, so we can think of as follows. We can think of this as being cosine of 27 degrees, and this is being sine of 27 degrees, but the hypotenuse length is 3, so we have to multiply all the side lengths by 3. So it means the side length that's closest to the 27 is going to be 3 cosine of 27 degrees, and the side length opposite is going to be 3 sine of 27 degrees. Okay, in the next video, I'm going to let these angles right here actually be arbitrary, so just labeled as theta again, and we're going to be looking for different formulas in a different type of situation. Okay, thank you for watching.